Alright, you've seen those YouTube videos on how to make a Christmas song. The ones that tell you which jingles to jangle, which bells to ring, how to sprinkle in a cozy fireplace crackle. Yeah, we're not doing any of that. We're using data science to write the perfect Christmas hit. When we first started this channel, I got really excited because I had a great idea. I was going to use data science to write the perfect emo hit because I was a former emo kid and a current emo kid too. But you know how these things work, right? The schedule slipped, Halloween happened, all of a sudden it's Christmas. And so I thought, do you know what? I can just reuse this format, make the perfect Christmas hit, and then turn it into a series where I can use the same model again and again and again. Are you ready to find out how wrong I was about how easy this would be? Because strap in, we're doing some real-world data science on some real-world data, and it's a real-world pain in the ass. So what goes into a song? Well, there's a number of ways I could take this. There are things like the sorrowful lyrics to Last Christmas or the heartfelt pleas of All I Want for Christmas Is You. But I could take the exact same lyrics that tug at your heartstring in one song and put them over a completely different melody and chord progression and ruin the song for you entirely. I mean, imagine if I put It Goes Like This, the fourth or fifth, over a descending chord progression. It would sound something a bit like this. Ruins it, doesn't it? So it's not just lyrics we need to understand a song. There's also the key, which can affect the notes that are used and how easy or hard it is to sing. There's also speed, which affects how much we want to dance to it and how quickly it moves. And oh yeah, danceability. That is actually a thing that is measured too. There's also metadata about the song. A huge amount of Christmas songs are covers because who doesn't like to do their own version of a Christmas crooner? On top of this, duration is important. We need to know how long the songs are, and we need a yardstick by which we can measure things. So how about total number of streams on Spotify? But there is a caveat here. We do need to normalize that by year of release or year it went on Spotify. We'll talk about that later, because there's no point comparing White Christmas, which has been out forever, to something that was released in 2025. So on the first day of looking at this problem, I thought I struck absolutely gold in finding the Spotify for Developers API. I went for lunch and then excitedly told my team that this was going to be way easier than I thought it was going to be, and oh, you sweet summer child. Here's a list of problems I had with the Spotify API in no particular order. Number one, I found the Spotify API documentation absolutely awful to work with. I really didn't understand how I was meant to set it up in the first place, so I decided to ask my buddy ChatGPT, despite knowing the fact that vibe coding never goes well, and spoiler alert, it was horrible. Everything I tried didn't work. It was just an absolute nightmare. I don't know why I bashed my head against vibe coding, because it never works. So take this as a lesson, future Lee and everyone watching. Program stuff on your own, kids. You'll be far quicker. Number two, the stuff I needed from the API was deprecated in November 2024. I was sat a whole year later bashing my head against it, wondering why it wasn't working, until I found out the sad truth that everything I needed was gone a year before I was making this video. Number three, Spotify decided it would make a really helpful endpoint for playlists, but then it didn't include any Spotify curated playlists. I couldn't use any of the good Christmas stuff it's already put in place. And so I decided to take the first playlist that came back for Christmas. I looked at it and was like, yeah, it has 500,000 subscribers or followers or whatever Spotify calls it. That must be the most popular one. Let's just use this. And then days later, found out that that wasn't even close to being the most popular Christmas playlist, but I'd already done all the work by then, so I decided to stick with it. So as you can imagine, I was quite annoyed that day. So much so that actually that evening, Liv texted me to check that I was okay, and I had to rather embarrassingly reply, yes, I was just doing data science. But in the end, I did use Spotify for a few things, namely release date and duration, and even that was missing for 4 songs out of 200, which is quite a fair chunk. I wanted to use Spotify's popularity score because I couldn't get raw Spotify play counts, but the popularity score is weighted with a recency bias, and because I was doing this in November, I couldn't wait for all the Christmas cheer to catch up. So what did I do for it instead? Well, I feel like I need to give back my data science title when I say that I did this manually by hand, clicking through every song on the playlist to get the raw number of plays. I also used this opportunity to write down whether it was a cover or not, or whether it was an instrumental, so I made myself a little real-life Lee for loop. So I'd got a fraction of what I intended, but the rest should be easier. right? Turns out there are loads of websites that curate information about songs, lyrics, all that good stuff, and make it freely available online for people to look at, but all of them now have protections in place to prevent scraping. And so I turned to ChatGPT to help me solve this problem, and you know what it said back to me? I can't do that. It would violate the terms of service. You wanna know what I said back? You were literally made by scraping the entire web. It is your fault that I can't get what I need right now, and all of this is so much harder. Then we got into a bit of debate about all the legal challenges that are going on, and that was a big waste of time. But I do have to say, right now, from my whole heart, you, ChatGPT. So my Lee is a robot for loop from earlier on. I managed to grab all the lyrics to all of the songs by searching them directly. I grabbed the lyrics from an amalgamation of loads of different sites, so I had to write a function to clean them up afterwards. But actually this part wasn't too bad. It took me maybe like a couple of hours. Getting the music features that I wanted though, oh boy, that was worse. Because it turns out there was nothing online that I could scrape to get the features of music. And so I did find a Python library called Essentia that I can use if I have MP3s, but I don't have an MP3 collection of Christmas. So I was ringing around everyone I knew that might have Christmas algorithms, and let's just say, Mum, I'm so glad that you love Christmas as much as you do. And then when I looked triumphantly at my list, ready to go, I suddenly realized, where's Slade? The Pogues? The Darkness, Band-Aid, where are all the cornerstones of my childhood and Christmas? And that's when I found out that all of these bands are actually British, and it's my model, so you know, if I want to make it a British Christmas, I'm going to make it a British Christmas. So I grabbed a UK hits playlist, stuck that into the end of my original playlist, and I was ready to go. So cool, after 2 weeks we have lyrics, MP3s, metadata. I think it might be time to actually do some data science. Shall we get stuck in? So I got about 5 years into my quant career before I found out what feature engineering was, and embarrassingly misheard it as future engineering instead. So I'm not going to assume this is something that's well known. I'm going to take a second to explain exactly what it is. So on a high level, this is choosing what features might be important to use in a model. So for example, I could take the lyrics of all the songs and just stick it into a model, but I only have about 200 songs, and with loads and loads of words in the lyrics, it's just unmeaningful to stick that much of information through. I actually need to pick out the salient features that I think might be important. Lyric data is made up of words, of course, so I needed a way to find out what kind of words are significant. And one easy way to do this is just to find out what the most common words are, but then I'd end up with words like the and all of those filler words that are all over the place, but not really meaningful for what's important from this song. So instead, I use something called the TF-IDF. Caroline did a great video talking about what the TF-IDF was in the past, so you can go back and look at that for an explanation. But on the Cliff Notes version, the TF-IDF gets the most common words that are different to the general lexicon. So words like Christmas, baby, snow, Santa, along with words like let's, was really important in this particular data set. So much so that I used the 5 of those as parameters in my model. And for good measure, I gave each song a Christmas score based on a document of Christmas words that Caroline found that was designed for kids, but we're using it anyway to get an overall idea of how Christmassy each song is. I had to think of other useful features that I could pull from this data set. So one thing that's really important about Christmas songs is they have to be sing-alongable. And so no using long words like onomatopoeia, just a lot of onomatopoeia instead. This means the reading level is probably important. So I use the flesh reading level function to be able to score this. Other features that are common in songs are rhyming and repetition. So I use the NLTK library to get an idea of the proportion of lines that rhymed and also how much it repeated. Next, I thought about some of the most common features of songs. So think about Mariah Carey's All I Want for Christmas Is You. She is talking about you over and over again, as well as herself. And so I thought it might be interesting to consider the pronouns used. So do people like it when we talk about ourselves, or would they rather be addressed directly? Let's stick I, we, you, he, she, they in the model to find out. Finally, for lyrics, I wanted to understand whether Christmas songs tend to be positive, negative, or more neutral, and my gut instinct said they would be positive, full of Christmas cheer. But then I realized that Last Christmas, that's not exactly a cheerful song, so I might need to check my assumptions here. I also didn't just want to do a sentiment analysis of the song, because part of the beauty of songs is the stories that they tell, those moments of tension and resolution, the emotions that build, and also those moments of calm so that you can get a little break to hit that like and subscribe button. All right, that covers lyrics. What about the music itself? Well, if you haven't been able to tell by now, you certainly will by the end of this video that I am a massive music nerd. And so I had these big ambitions to be able to map the chord progressions of every single song and stick that in my model. But I realized relatively quickly that that was overcomplicating things a lot. And I was kind of running out of time to make this video. So let's move on. Instead, we use beats per minute, a measure of how fast a song is going. Danceability, how much you want to get up and dance that rather than sit and relax. We also can look at the chord changes rates, which gives an idea of how quickly the emotional undercurrent moves underneath. On top of that, we can also look at the tension of dissonance versus the smoothness or consonance. And finally, the key and tonality, which gives us an idea of whether it's a happy song or more of a sad song. I one-hot encoded the keys and set that and tonality, is cover, is instrumental, all to binary. Everything else in the data was numerical, including the duration that I mentioned earlier. Right, we have all the data we need to model. Should we do some modeling then? So initially I was going to build a bog standard multilinear regression algorithm, but I actually have a bit of a problem because I have some multi-collinearity in my model. Take for example the word snow. I'm actually using that as it's the most common word. I'm actually using that as a variable in itself. But I also have the variable of Christmas score. And last time I checked, snow is generally considered a Christmas word. This means I can't treat the two of them as independent variables because the Christmas score is very much dependent on the word snow. So I have to deal with the collinearity in my model directly. So instead, I wanted to upgrade my model to reduce potential overfitting, and I had two main choices for this: ridge regression and lasso regression. Ridge prevents overfitting by adding an L2 penalty to the model. And this is good because it reduces the size of large coefficients, but it keeps every single one of the features I mentioned earlier in the model. And that's a little bit of a problem because constraints are good for creativity, but too much constraints and I'm not really going to be able to get any kind of creative song out. I'm just going to be optimizing directly to those constraints. Lasso is the other main option. It will force some of the coefficients to zero, leaving us only with the main features that are most impactful. However, our model is very multi-collinear, and that means that it could have some false flags. Like, say it picks the word snow as the most important and it zeroes out everything else that's collinear with that. We might not get to see the effect of words like Santa or Christmas or the Christmas score in itself because of that. With such a small sample size, we can't be sure that picking only snow is the right decision. Fortunately, it is possible to have the best of both worlds. ElasticNet regression uses both penalties from ridge and lasso, allowing us to zero out the features we don't need, but also capture correlated features. So that's a good choice for model. Let's get feeding it. A few minor points before we do. Some of our data is pretty big in absolute terms compared to other data, for example, reading age versus repetition count. So we use standard scalar from scikit-learn library in order to make things a little bit more fair. We're also going to log transform the streams per year because this is highly skewed towards All I Want for Christmas Is You and Last Christmas, and we want to make it look a little bit more normal. Because an extra 10 streams to one of those songs isn't really very impactful, but for a song that came out in 2025 that is only just getting that Christmas spirit, 10 streams could actually be a relatively big impact. This is also particularly important because things can be skewed by the artist. I mean, everyone loves Mariah Carey's All I Want for Christmas Is You, but I don't think she's going to pick up the phone if I ask her to come and sing my song. Finally, we need to work some magic with our keys. Right now we're one-hot encoding them all, but this gives us a matrix where every single row sums to 1. And while linear regression can't handle this because it can't invert it, ElasticNet regression can, but it's numerically a little bit unstable. So we drop one of the rows, let's get rid of the key of C. Pianists hate that one anyway. Then if all of the columns are 0, we know that C is the one to go with. Okay, we are finally ready to run the model. Ready to see the formula that makes a perfect Christmas song? So what we wanted from this model was for a significant number of our terms to zero out. And in fact, that's exactly what we have. And a few terms that are hovering near 0 as well. So we can scan down the list and pick out only the most impactful terms to use to tell us what to do to write a good Christmas song, but more importantly, what not to do. Let's talk about what not to do first, because the model is very clear on a few different things. First and foremost, do not write a cover, which is really good because I was planning to write a song at the end of this video anyway, and I don't really know what I would have done if it had ended up being a cover. Secondly, do not write in the key of F sharp ever, and I don't know why you would do that because it has 7 sharps, so I'm really glad I don't have to do that. In terms of words, the model believes pretty strongly that we should be using the word snow a lot. Oh, Liv, write that one down. Thank you. Also, Christmas and Santa, they're pretty common as well, but never ever use the word let. Let's move on from that one, shall we? Interestingly enough, the Christmas score was zeroed out to say it has no effect, and that's probably because all of the data I gave was Christmas music, and there were a lot of covers as well which didn't perform as well. It's a moot point because we're going to write a Christmas song anyway, so we're going to get the Christmas score either way. My duration leans slightly longer than the average according to my model, so we want a song that's about 3 minutes and 43 seconds overall. The model gave me round about 0 for BPM, so we take the average of the data set, which comes out at 125. For pronouns, it was pretty neutral. It had a slight preference for we, and that's pretty lovely, isn't it? The stuff that gets really interesting is when it comes to sentiment, because unsurprisingly, the model said that the song should be pretty upbeat, it should have a pretty positive sentiment. But what gets really interesting is when you dive into the narrative arc, because actually, the model feels pretty strongly that the song should actually have a negative ending. Well, okay, I can do that. I can write something that's bittersweet. But what is also really interesting is that the model had a little tug towards minor keys, which sounds sad, which leaves me with a little bit of a conundrum. I looked at my keys and there was actually a really strong preference there as well, with A flat leading the pack by a landslide, but C sharp really close behind. And I thought about this and I decided that no one is ever writing in A flat minor because again, it has far too many flats. So if we're gonna go minor, let's go C sharp minor instead. That's much more manageable and something I can get to work with. So I put together a chord progression, wrote a bit of music, and came to the conclusion that this sounds absolutely depressing and not Christmassy at all. So I decided it's my model, I can have a little bit of creative license in how I interpret it. So I decided I was going to jam together both A flat major and C sharp minor, which is musically actually pretty difficult. So thank you, Slade, for helping me work through the transitions there. Woo! And finally, I had to add a moderate amount of dissonance, which means those crunchy chords that are often found in jazz. So I had to pull out my jazz guitar learning again, and I got to use my favorite chord, C sharp minor 9. Add in a few suspensions and dominant sevenths, and then we have something that feels jazzy enough to be Christmas without being too jazzy that no one knows what's going on. So that's it, the formula for the perfect Christmas song. Take A flat major and C sharp minor and jam them together with a little bit of Slade magic. Take a song that is generally positive but give it a really depressing ending. Repeat yourself a lot, particularly the word snow, and never ever ever write a cover. Well, I bet you want to know what it sounds like now then, don't you? Well, much like an encore, if you would like me to come back on stage and perform it to you, I need you to like and subscribe right now, and I will be right back with maximum cheese for Christmas.
I can see the snow falling down. It makes me feel like Santa's really riding around. And I know the snow only comes out to play when I'm falling in love. with your parents instead. And maybe we have been moving too fast to fall in love. I never saw the snow falling down, makes me feel like Santa's never coming to town. And I know the snow still won't come out to play, 'cause I'm losing